Welcome to our scatter plots and lines of best fit project. Today you're going to learn how to graph data as a scatter plot using Geogebra, learn how to model the data with a best fit line, convert our equation to slope-intercept form to make predictions, and lastly discover how the slope of a line can be used to describe the rate of change. Our data is fictitious. It's ice cream sales versus temperature data. And what it is temperature outside in Fahrenheit and sales in dollars at the grocery store. So the very first thing we're going to do is plot our data using GeoGebra using the spreadsheet and graphics tool. The reason why I choose this tool is because instead of inputting each data on the input line, each data point, you could make an error or something. This is the most accurate and the best and efficient way. So over here is a pop-out window. I just touched it, spreadsheet and graphics. Now we're going to go to our data and we're going to highlight it, Control C, then go over here. There's 10 data points, so we're going to go down 10. Control V. Well, here's our data, but it's not on our graph, so let me show you how to do that. You actually have to highlight it, right-click, create a list of points. Then move back to our algebra or algebra and graphics view, here algebra view. And now our x values are our domain and our y are in range. Our domain is somewhere in the 50s to 70s. So we're going to move our graphics view and collapse our x values, the domain, so they're between the 50 and 70 degree Fahrenheit range. We still don't see our data because we have to collapse our y values, which are sales. So let me do that. So in between the two y values, I'm going to collapse them, and it's going to somewhere between 200 and 600. Now, I want to make sure I have a point for each of these, so I'm going to over here, I'm going to show label. There we go. You can still move your graphics view so you can see your graph better. And the very first thing I'm going to do before I get to our worksheet is I'm going to go over here, meaning before I get to these questions in our worksheet, I'm going to label our graph, temperature in Fahrenheit. So I'm going to go to my thing right here, this is my text box, and my X is temperature in Fahrenheit, because we always need to label our graph so we know what this is about. Sales in dollars at grocery store. So I'm going to put that right here. Control C, Control V. You can type these in if you want to. I'm going to move this so I can see it better. So now let's go to our worksheet. Let's answer these questions together. What type of correlation is this? Positive, negative, or scattered? Well, it looks like it's increasing. As the temperature is increasing in Fahrenheit, the sales are increasing. So this is positive. So let's write that in. Write the equation of the best fit line in slope-intercept form. There are two ways to do this. One, you can go under here at the very bottom. There's a best fit line. You highlight it and it gives it to you. So we're not going to do it that way for today. We're going to use the line tool and find 2 points that we agree on, because you're going to be doing this with your partner later. And I'm going to say G and B. Now this equation is not in slope-intercept form. It's ax plus by equals c. A is positive, so it is in standard form. How do we convert it? Well, we're going to let GeoGebra help us. Equation y equals mx plus b. There it is in slope-intercept form. You cannot copy this into your worksheet. You have to type it out. So I'm going to write it out right here. Oh, I'm going to move this over so I can see it first. So y is equal to 18.53x minus 814.33. And I think I do have it correct. There we go. What does the slope of the line represent within the context of your graph? That is a very good question. So there's our slope. M is equal to 18.53. Let's review the slope equation. So M, the slope, is equal to, let's look at that equation, y2 minus y1 all divided by, so I'm going to put a line here for divided by, x2 minus x1. Put that on the board here. So it's a change of y divided by the change of x. So let's write that down in a text box, because that's what it really is. It's a change. Slope equals change of y all divided by change of x. So I'm going to put that down here. And now let's put this and look at our slope, 18.53. So let's write this down. M is equal to 18.53. Instead of the change of y, we're going to put the units of y, which is dollars, divided by the units of the x, which is degrees Fahrenheit. And divided by also is per. So if we are going to interpret this, it says that for every it 18.53 dollars per every degree Fahrenheit. So the sales are going up $18.53 per degrees Fahrenheit. Let's write this over here. So sales are going up $18.53 per degrees Fahrenheit. Now the next question. What do you predict the sales to be at 90 degrees Fahrenheit? So to do that, you're finding when this is 90 degrees, where does it intersect? We'll go to our input line and write x equals 90. Now there's actually an intersect tool. We're going to intersect here and read it. When x is 90, the sales are 852.98. So $852.98. So now read the next question. What do you predict the temperature to be if there are $700 worth of sales? So in other words, when y is 700, let's see what the intersection is. Go over here, and it says the temperature should be 81.74 degrees. What is a reasonable domain for this function given the data in the chart? Very good question, because if I intersect right here, and this is when it's 43 degrees, it says there's no sales. Or if there's a number less than 43 degrees, there's negative sales. So that goes to show the domain, which is the x values, cannot really be outside of what the given data is. But you could predict a little bit outside of it because we already did that. I'm just going to delete this because when we said we did this one when it was 90, the sales were predicted to be 852. So I'm just going to take my pen, and reasonable would be somewhere in here for this data right here. So the x value is somewhere about 50 degrees to about 90 degrees. It's not exact, but it's close enough. So I would say, because it's reasonable, 50 degrees to 90 degrees. And anything under that is not reliable because it's going down to such a small amount of sales. And I hope this helps you. What you and your partner are going to do is you're going to collaborate, and you're going to choose one of the data sets below: cost of repairs versus number of oil changes per year, median salary versus years of education. You are going to use this GeoGebra and follow the steps and answer the questions in your worksheet. I hope you enjoy this project, and thank you for attending.